Welcome, students, to Part 1 of our Organic Chemistry lecture series for Chapter 17 on carbonyl compounds. When you're done studying this chapter, you should be able to provide IUPAC names for simple carboxylic acids and their derivatives. You should also be able to explain how carbonyl compounds react, and you should know the various reactions listed here. Just so you know, we will skip sections 17.2, 17.3, and 17.13. As I've stated earlier, I want you all to keep the big picture in mind as we dive into the trenches of learning numerous chemical reactions. Why do we have to know so many? Because once we know them, we can use them to assemble almost any useful molecule imaginable. Carboxylic acids and their derivatives are often called carbonyl compounds. A carbonyl, simply put, is a carbon-oxygen double bond. As you can see in this slide, there are 9 different kinds of carboxylic acid derivatives that we will discuss in this chapter. Aldehydes, ketones, carboxylic acids themselves, acid halides, esters, thioesters, amides, acid anhydrides. We will later address just briefly acyl phosphates. Aldehydes and ketones, which are featured at the top of this slide, are different from the remaining compounds down here because they don't have good leaving groups bonded to their carbonyl carbons. All of these other carboxylic acid derivatives have fair to good leaving groups bonded to their carbonyl compounds. These leaving groups include this OH, this halogen, this OR, this SR, and so forth. Aldehydes and ketones, in contrast, have a hydrogen or an alkyl chain bonded to their carbonyl carbons. Hydrogens and alkyl groups are not good leaving groups, not like an OH or a halogen or an OR. Because of this difference, aldehydes and ketones react differently from all of these other carboxylic acid derivatives. This will become more apparent as we move along. Here we see several biologically relevant carboxylic acids. Pyruvic acid, for example, is a key intermediate formed when our bodies convert sugar into energy. Succinic acid and citric acid are also key intermediates traversed during metabolism. The prostaglandins featured down here are responsible for numerous biological events, including the regulation of muscle contraction and relaxation. I'll now guide you through the necessary steps of generating a systematic IUPAC name for simple carboxylic acids. First, we have to find the parent chain, which is the longest carbon chain that contains the carboxylic acid. Second, we have to number the carbon atoms in that chain in the direction that gives the smallest number to the carboxylic acid. In other words, the carbon in the carboxylic acid will always be position number 1. Third, we have to write the name as a single word. We write the parent chain, and we replace the E that would normally be present in that size of parent chain. For example, ethane or propane or butane. We replace that E with the suffix oic acid. If there are any substituents along that chain, we list them in alphabetical order and use prefixes di, tri, etc. If the same substituent is present multiple times in the molecule. So here are some examples that I've given for you to look at. You'll notice this first example has 3 carbons long. A 3-carbon long chain, by IUPAC standards, is called propane. Because this is a carboxylic acid derivative of propane, we start numbering it at this carbon being carbon 1, this is carbon 2, and this is carbon 3. We take off the letter E at the end of the word propane and replace it with the suffix oic acid. Thus, this compound is called propanoic acid. If we look at this compound, we will count the number of carbons in the longest chain containing the carboxylic acid and see that that chain is 5 carbons long. We number that chain, of course, beginning at the carbonyl carbon. This 5-carbon long chain, under IUPAC standards, is normally called pentane. Because this is a carboxylic acid, we replace the E at the end of pentane with oic acid. So this is called pentanoic acid. This carboxylic acid has a methyl group dangling as a substituent off of carbon number 4. Thus it is called 4-methyl pentanoic acid. This is an interesting compound. It has 2 carboxylic acids, one at position 1 and the other at position 8. We number in this direction going left to right because it gives us the lower number for the substituents. Selecting the opposite direction for numbering would give the same numbers to both carboxylic acids. So differentiating between the two directions is done by giving the direction that gives you the lower number for the substituents. This compound has 8 carbons, which is normally octane. We replace the letter E, however, with the suffix dioic acid, because there are 2 carboxylic acid groups in this molecule. Thus, this compound is called octane dioic acid. Because it has an ethyl substituent at carbon 3 and a methyl substituent at carbon 6, we place these alphabetically according to the first letter of the substituent's name here at the beginning of the name. Thus, the full name is 3-ethyl 6-methyl octane dioic acid. Acid halides, which look just like carboxylic acids except that the OH has been replaced with a halogen atom, are named by following the same steps used for carboxylic acids except that we replace the letter E in the regular alkane name with the suffix oil bromide, oil chloride, or oil iodide. Here are a few examples. This compound has got 3 carbons in its main chain. 3-carbon long IUPAC name is propane. The systematic name for this compound would be propanoyl chloride. This name right here written is actually a common name, propionyl chloride, which is also acceptable, but the IUPAC name would be propanoyl chloride. This compound has 4 carbons, which is a butane. We call it then butanoyl bromide, and it has a methyl substituent on carbon number 2. It is therefore called 2-methyl butanoyl bromide. This entire compound is 4 carbons long again. It is a butanoyl iodide. Coming off of position 2 is a methyl and position 3 is a chloro. The full name, therefore, is 3-chloro-2-methyl butanoyl iodide. For acid anhydrides, we follow the same convention except that we replace the letter E in our parent chain name with the suffix oic anhydride. If we look at this anhydride, for example, we'll see that the longest carbon chain here is an ethane. We therefore replace the letter E with the suffix oic anhydride. So this is ethanoic anhydride. You'll notice that this parent chain is a benzyl group, so we therefore call it benzoic anhydride. And this compound, which actually doesn't follow a straightforward conventional name for you guys, is just one that I thought I'd throw up here. It is called succinic anhydride. The way we name esters is by first naming the alkyl group that is dangling off of the ester oxygen. We then find the longest parent chain that includes the carbonyl carbon and replace letter E with the suffix O8. Any substituents we list at the beginning of the name in alphabetical order. So let's take a look at this ester right here. First of all, I have to figure out what is the chain dangling off of this ester oxygen. It's 2 carbons long, so I call it ethyl. The ester portion of the molecule itself has 1, 2, 3, 4, 5 carbons. A 5-carbon long chain is normally called pentane. Because this is an ester, I replace the letter E with the phrase O8. Thus, this compound is called ethyl pentanoate. Over here, we'll see that we have a cyclohexane dangling off of the ester oxygen. So we call it cyclohexyl, and then this ester portion has 6 carbons in it, beginning from the carbonyl carbon. So it becomes cyclohexyl hexanoate. This compound has a methyl group dangling off of it, and it has a butane coming off of this. So the IUPAC name would be methyl butanoate. Methyl butyrate is actually a common name for this. This ester has a methyl group coming off of it and 3 carbon long chain that we would normally call propanoate. So the IUPAC name would be methyl propanoate, or if you're using common nomenclature, methyl propionate. This compound would be called methyl ethanoate because it has an ethane in the ester portion of the molecule. A common name for it, however, is methyl acetate. Amides follow the same convention except that we replace the letter E with the suffix amide. We can see this exemplified in these various examples. This compound has 2 carbons long in its chain that includes the carbonyl. 2 carbon long chain is normally called ethane. We would replace the letter E with the suffix amide. Thus, this compound would be systematically named ethanamide. The common name for it is acetamide. This compound has 6 carbons long in its chain, including the carbonyl. That is a hexane. We replace the letter E with amide, so it is called hexanamide. This amide has a cyclopentane group coming off of it, but it's got this carbonyl in the middle of it, and so it's really difficult to come up with a straight chain name for this whole thing, including this carbon. So the way we handle that is by considering this cyclopentyl group to be almost like a substituent. We call it cyclopentane carboxamide. Carbox is a phrase that denotes this carbonyl in the middle. Now here's an amide that's kind of interesting. This is an amide that has a methyl group coming off of the nitrogen itself. How do we handle that? Well, we name the base amide itself by counting how many carbons there are in the parent chain. There are 3. So it is a propylamide or propanamide. But then to denote that there is a methyl coming off of the nitrogen, we at the beginning of the name put an italicized letter N with the substituent name methyl. So it's N-methylpropanamide. This is another example like that. We consider the cyclohexane to be one group, this carboxy group to be in the middle, and the amide has 2 ethyls coming off of it. We therefore would name it N, diethyl cyclohexane carboxamide. When naming nitriles, that is compounds that have cyano groups in them, we find the longest parent chain that includes the nitrile carbon and then just add the suffix nitrile to the end of it. So this nitrile has 1, 2, 3, 4, 5 carbons in it, and I include the carbon that's triply bonded to the nitrogen. A 5-carbon long chain is called a pentane chain. So to denote that it is a nitrile, I call it pentane nitrile. This compound, following the same convention, is called hexane nitrile. This compound would be called butane nitrile, or if you're using common nomenclature, is known as butyronitrile. This compound would be called propane nitrile, or using common nomenclature, propiononitrile. That's kind of weird. And this compound would be ethane nitrile, commonly known as acetonitrile. This seems like a great place for us to conclude this part of our lecture. Before doing so, however, I wish to leave you with some practice problems which I won't solve for you here. For help, please feel free to consult me in class. After you're done with this video, I hope that you'll go on to part 2 of Chapter 17.